Oh, it's quite a crowd. Let's get there. You guys are also 36. Or because this one goes. What's yours? Fair enough. That's fine. We just came in on Monday. I came in. Oh. You just love it. How are you liking it? And then we started. So it's my other two fathers. They're also in grad school. Shall we? Everyone, I think everyone's here.
I guess I'm sharing this.
Yeah, that's large remote participant.
Yeah, makes sense.
Yeah, I think we're good to go.
You're good to go?
Yep.
All right, gentlemen, ladies and gentlemen, thank you for making yourself available today. As for whoever hasn't had the invite, the idea behind today's event is that we've seen a trend in the industry how AI-first companies are going about building their artificial intelligence and machine learning infrastructure. And we'll quickly walk you through how these top companies do it, and then we'll talk a little bit about how you can basically emulate these best practices in-house and basically get the same results that these people are getting, and that's the reason that they're creating this competitive advantage. But before that, we'll quickly give you a rundown of who we are, what our story is. So Farooq, Umar, and I, we've been working together for the last 6 years, at least together. We founded this at Duke, where I was a grad student, Farooq was a freshman, and we came up with something which was related to retail, but it was basically hyper-contextualized, hyper-local messaging in retail. And we started off with that project/company, and once we built the stack, we realized that machine learning on top of that stack is what would add real value. And we went out shopping for systems that would let us build custom pipelines in machine learning. And that's when we realized that there's really no product out there in the market which caters to that need. And so we switched over to what we do now, which is Dataspine. That's our company. We have a platform that lets you build enterprise-grade machine learning applications with minimal effort, and which will be at par with the bigger companies like Airbnb, Uber, Google, Facebook, etc. And without further ado, I'd hand it over to Farooq.
Awesome. Farooq here. This is Omar, guys. And so we're going to quickly walk you through some of the infrastructure and workflow-related best practices that we've seen, throughout our careers. And then, we know that this is going on in, companies like Uber, Netflix, you name it. But being AI first, a lot of this depends on the infrastructure and how you're doing it, rather, right? And that literally determines, everything in your roadmap, such as how much technical debt you'll incur, things like that. And then eventually, if you're building AI and ML products, which I believe most of you here are doing, this is basically directly affecting your business, right? So these things are very crucial for anyone who's doing ML and AI, but especially for someone who's productizing it, right? Let's start. Yeah. Okay. Right. So Google came up with this paper in 2014 in which they termed machine learning as the high interest credit card of technical debt. And this is Google, right? So probably the biggest AI first player in the industry. And the reason they came up with this paper is because they have been building production ML systems in-house for a while, as they have been with other parts of their infrastructure. And one illustration in this paper that was cool is this one. So a lot of us, when we go about building a AI or ML powered product or a feature, we usually think of the ML logic as the core part, right, which is your model. And sure it is, but that's just a part of it, right? So if you're taking things to production at scale, this is the reality. So ML code, in fact, is only a tiny portion of what you do, whereas there's a lot of other logistics involved with the workflow, such as managing config, the data pipelines, feature extraction and updating all these things. Then the infrastructure part, which is like the machine resource management. Then if you're using analytical tools of your own choice, all of this is a huge part of what would comprise of your workflow when you're doing it at scale. And these things are very nasty, right? So this is the experience that we had when we were trying to build a production ML pipeline ourselves first, that a lot of these pieces are disjoint, and you require a lot of dedicated DevOps expertise to do it, right? The problem here is the DevOps or infrastructure space itself is evolving so rapidly that it's very hard to keep up. So, for example, just a quick show of hands, how many of you here have heard of Docker and Kubernetes before? Cool. How many of you have actually worked with it? Docker containers, all right. So these are like the new emerging standards, right? However, if you actually right, so this is how it happens today. So all the top tech companies, what they have is internal proprietary machine learning models and in-house infrastructure and pipelines that are built by dedicated teams, and they're constantly there to maintain it. So, for example, Quora built their own machine learning platform instead of going for an off-shelf solution, because they realized that the kind of integrations they need with the Quora product and let's say the data sources within the organization, it simply requires them to build something custom. Facebook was one of the first players who built an internal ML platform called LearnerFlow, and then 2017 Uber released Michelangelo, which is one of the you can say the most sophisticated platforms out there. But they're all closed source. So what we've seen is these AI first companies, they're almost a lot of their competitive advantage lies around infrastructure, right? So the faster they can iterate and productionalize ML across the organization, products and different teams, that's the race here, right? What about all of us, right? So if you go and do all of this on your own, it's basically like a huge mess, right? So first of all, it's very complex in the sense that these are all different workflows requiring different tools, different dependencies, different stacks, and just staying up to date with all these is a huge pain, right? Then a lot of these, even if you manage to, let's say, spin up your own Jupyter notebooks, a lot of these workflows are very manual, right? So you have to kind of do these things over and over again. And even if you automate parts of it, the rest of the stuff, if you build in-house, it quickly grows non-standard, right? And what I mean by that is if you keep building something in-house, after a point, like you'll have to put in a lot of effort to maintain it if like you want to keep up to date with all the versions, like and things like that, right? And then it's very expensive, right? So Uber, Quora, they all have 10 to 15 person infrastructure teams which have built these platforms over like a year or two. So if you want to do this on your own, you can imagine right now how much of effort that would be. So what do we do? Right, so before we get into the details, here's what a typical ML lifecycle looks like, right? So you would start with a problem typically, you do some experimentation, come up with a model, train that model, deploy it. Usually, like until here, this is the part that most of us do, right? At a smaller scale, perhaps, but we all know how models are trained. Like you use GPUs, like and things like that. But if you go into production, there's an additional component to that, right? Just how you maintain and operate on regular software applications, do DevOps. There's a DevOps component to ML as well, and when you put this in terms of an ML product, this loop needs to be continuous. Right? So that's the biggest takeaway here, that you cannot simply just train a model, take it out to production, and then sit out, right? Because it'll start deprecating the moment it goes live, right? And it's only as good as the data got. So there needs to be a way that you can operate on this model. Let's say if you want to retrain it, update features, things like that. So these are all the logistics that are currently a huge pain. Okay, so now I'm gonna come to what some of the bigger players here are doing, right? So we're gonna look at 3 platforms in the industry. All of these are closed source, but we have access to those architectures, and there's a lot of common themes across all of those. So let's look at how Airbnb does machine learning in-house. So on a higher level, this is the overall architecture. They have a platform called Big Head. And basically it provides the end-to-end machine learning infrastructure for every product and team at Airbnb. So if you look at beginning, typically there's both an offline and online portion. So these web scale companies, almost all of their products are now AI powered. So for example, your Netflix, every row that you see is powered by a different recommender engine. Similarly, if you are in Airbnb, the recommendations you'd get, they're almost near real time. So things like that. So there's an offline component, there's an online component, and then it typically starts with their data pipelines. So these are all obviously in-house because they're tied to their data lakes or whatever data sources they're using. But then there's a part where you automate your workflow using Airflow. So that's a tool that they internally developed. Redspot is their way of spinning up Jupyter notebooks based on whatever stack they want for their data scientists. Then the data scientists author these models. They go into a central model repo. And then from there, that's typically where their CI/CD starts, you can say, where models are pushed into production through online serving microservices, and then they're consumed in clients. And then there's a service which updates their features, right? So a lot of these things are internally built there. I don't want to get into too much detail, but the point here is it requires an end-to-end, infrastructure to operationalize, their models from end to end, and at that scale. Uber has something called Michelangelo. That was the platform they had initially developed. Starts with their data pipeline, so they use both online and offline. They have so they use Kafka, Cassandra, Spark, and all these big data technologies for their data pipelines, pre-processing. And then you come to the ML workflow where they have training jobs and similar service where they author their notebooks. And then evaluation happens in real time. So all this is a complex pipeline, but you can see that this is somewhat similar to what we saw in Airbnb's architecture, right? So it's there's a whole lot of different bits and pieces. They're disjoint. There's both online and offline layer. And all this is real time, right? So continuous. Basically, more data comes in, the models get retrained, they get deployed, and that's how it's all automated. So, for example, Uber Eats, if you call, call the Uber Eats, the ETA that you see, that's powered by a near real-time ML model, which updates based on historical data. So that's a good example, right? So everyone who calls an Uber Eats has a predictive model behind that, and which is serving real-time predictions at that scale. Then after Michelangelo, which was developed in 2014, Uber realized that the way they were training their models was very locked in the sense that they were only using Spark. So they were using Apache Spark for distributed training and deployment, but you had to write models a certain way in order for them to work on Spark. So they came up with something called PyML, which is very recent. So PyML...
this was about 3 days ago, right? But then
Michelangelo. Yeah. So this is a layer on top of Michelangelo, and what this provides is a general purpose Python-based framework that lets you allow author models in any of the Python-based frameworks, and it's all a consistent workflow in the sense that let's say if you're using TensorFlow, you're using PyTorch, Keras, all of your dependencies would go into the requirements file, which you have with the model typically, and then there's a trainer, like a model PY, which calls the training or prediction services, and then the rest of the architecture is all connected to containers, basically, right? So once you have your model project in that way, it gets containerized, and then they use it for both online and offline predictions. So nowadays, Uber does ML deployment this way, and this is basically state of the art. eBay has something called Krylov. This is a bit blurry, so, don't get into too much detail, but things I want to highlight here is it's somewhat the same thing in the sense that this is using a Jupyter notebook server. It's running on a cloud native architecture. There's multiple layers. So data stores. Then there's a provisioning. There's business logic, and then there's the clients that the teams within eBay use, like the SDKs or CLIs. So the crux here is we see that there's a certain kind of approach that all these companies are following when they're developing their ML platforms. And let's look at some of these themes, right? So if you're working with big data, now the go-to choice is Apache Spark, but people are still using Hadoop, Hive, and all these things. So this is kind of like the standard for your data pipeline, right? So if you want to, I think you guys are not dealing with a lot of big data at this point, probably.
I know Ganesh's team is using Spark.
They are? Okay,
yeah.
Cool. So for instance, Spark is probably the go-to choice in your data pipelines now, both for processing and even for training, distributed training to an extent. And then ML and AI frameworks, there's you can say tribes within the industry. So Facebook's pushing PyTorch, Google's pushing TensorFlow, but on the top, they're all pretty mature frameworks now. So you either work with TensorFlow or PyTorch, or if you want to do classical ML, it's scikit-learn. If you want to do extreme boosting, it's XGBoost. So we've kind of converged on the standard stack for ML frameworks. And what we've seen is people want to use these frameworks on the on their own terms, in the sense that sometimes they want to develop TensorFlow models. Someone wants to develop PyTorch models. They all go through the same consistent platform workflow. Similarly, for infrastructure, we've kind of converged on Docker and Kubernetes as the gold standard for container orchestration. And this is something we've seen in almost all of these platforms. So they're all infrastructure agnostic. Some of these are hybrid architectures, so they're working partly on the data center, partly on the cloud. Sometimes they're all on cloud, but they're all built on Kubernetes, which basically frees them from whatever underlying cloud they're running on, right? So here's the some of the themes that we've seen in all these platforms. First of all, they're all end-to-end, right? So starting from data prep to model building, to notebooks, training jobs, deployment, and then monitoring, scaling, and post-production. All of these things are covered in these platforms. And then they're self-serve for the individual stakeholders. So data scientists don't talk to the DevOps when they're using these platforms. They just go and in a self-service manner, provision their notebooks, run their jobs on whatever compute they want, and then the ops stakeholders, they take care of whatever the deployment part of it is. So there's no silos and dependencies if they use a platform like this. Similarly, they're all cloud native, as we mentioned in the last slide. So we've kind of seen a convergence around Docker and Kubernetes. So using cloud native architectures has a lot of advantages, primarily the scale. If you're doing things at scale, it resolves a lot of the things that problems that come with a monolithic architecture, especially when scale of ML is so high, starting from training to predictions. So it's very unpredictable. It's very it can be very bursty, things like that. So cloud native is the go-to choice here. Similarly, they're all multi-framework. So Airbnb's Big Head or even Google's TensorFlow now isn't just built for TensorFlow. Previously, Google had a TensorFlow-only platform, but now as more frameworks have come in, these companies have realized that they want to provide their data scientists with the maximum flexibility, and hence they all support a multi-framework workflow that's consistent, right? So the same way you would train a TensorFlow model, same way you would train a PyTorch model, and then same with deployment, right? So that's very important because otherwise all these frameworks have different workflows and dependencies.
So just one question, just to give you some context, we were looking at some literature from MapR, and they polled their users who were doing AI, and on average, these enterprise level customers were using a minimum of 5 frameworks, maximum of 12 frameworks. So that's the kind of scale at which people operate when you're getting into AI at productions.
And elaborating on that, for instance, you can use multiple frameworks within the same pipeline, right? So for some pre-processing, you can use OpenCV, let's say, or you want to use scikit-learn. But later, when you if you have deep nets, you would use something like PyTorch. So even across the same pipeline, you would encounter multiple frameworks. Right. The fourth major trend that we see is they all keep consistent environments across the pipeline. What I mean by this is they're all using containers, right? So what containers lets you do is it avoids those dependency surprises that, hey, it works on my laptop, but it doesn't work in production or something like that. Okay. Secondly, it basically gives you a immutable way to work with these models, right? And do versioning and things like that. So almost all of these platforms now, the basic unit of infrastructure is Docker containers or other kinds of containers, but Docker is the most popular. And then for model deployment, almost all of these platforms leverage microservices and they're typically deployed on Kubernetes, so they can support things like auto scaling and advanced load balancing, metrics, things like that. And then one of the recent trends that we've seen is so usually these days in ML, training and testing happens, and then model goes into production. There's no way to test a model when it's live, right? And that's something that's changing. So in mission critical settings, what we're seeing is data scientists are now able to train and experiment with models in live production, right? And we'll show you in a bit how that's done. But basically, experimenting against a portion of your live data gives you much more power and accuracy over your model than if you're doing it in a siloed process where you're just developing the models and then they're being deployed and there's no feedback cycle involved.
Sure, peut-être. Là, il faudrait que je regarde.
Today, I'm primarily going to focus on production, right? So we mostly all get by with the part where we train our models on a notebook or even on your local machine or GPUs at scale. But a lot of the challenges in ML apps come in production, right? So we're going to walk you through some of the common workflows and themes here. So, for instance, in deployment, it's important to review your changes, deploy and easily roll back train models, right? So not just deploy and then forget about it, but being able to update them, retrain them, or roll back if they're falling in quality. That's very important. Similarly, you need to have a singular view of, the model health. So this includes the model-specific metrics, data visualizations, and then associated alerting. And ideally, this is all central. Similarly, experimentation, right? So not just do siloed experiments, but being able to set up live experiments, which I just said, and do advanced tests like A/B, or multi-arm bandits. That's something that all these platforms are employing, and that is something that's incredibly hard to do if you were to build it yourself. So now we're going to come to the real. Are you halfway through? All right, so before I go forward, do any of you have any questions or have any thoughts on what we talked about?
This can be applied to pretty much this is infrastructure.
No, this is
Infrastructure. I get the fact that it's very
Merci, Julien.
It doesn't just apply like general infrastructure. So how does that put Dataspine in? How do you visualize Dataspine? Like I'm right now looking at something you guys have made. Simply looking at it that way. So do you look at this expanding to other things as well, or are you purely looking at ML-based productions?
So that's a good question. So a lot of these infrastructure themes, especially around Docker and Kubernetes and microservices, that's something that we're seeing across the board. So every company, even startups, and if you go to very large enterprises, they're all kind of converging on this cloud native stack. What Dataspine provides is a way to do cloud native machine learning without having to build all of this, right? So right now our focus is on ML, but eventually, we would be able to support entire ML applications, right? So not just the model, but entire pipelines.
Right.
Actually.
But to add on top of that, what we've seen over time is that machine learning or smart applications are a different beast from traditional software, and therefore they have to be handled differently. So that's the reason we're tackling this problem first. But something in our product pipeline, and I think Farooq might talk about it later as well, is when we want to go to ML for deployment as well for generic software. It's not just smart applications.
Yes. To further your point, for example, it's fairly simple to build a simple Docker image these days, right? But if you had to build a Docker image for your production model, for example, there's a lot of things that go into it, and you have to be very careful about how that's done, right? So that's the part that we are filling, basically. So without that specific DevOps expertise, you can just carry out your ML workflows, whereas we take care of the infrastructure. That's the idea. Faisal?
I have a comment and a question. So the first comment is you're absolutely spot on about giving data scientists the freedom to actually run these experiments on their own. It reduces a lot of the effort that dev teams usually have to spend to get those experiments to go live. That's one. My question was, and this might be you might be talking about this later, in terms of A/B testing, for example. How much of that are you currently doing? So how much of that are you currently focused on in Dataspine, where you're hey, I have two models, I want to A/B test them. So that's that's one example of it. Or the other thing would be metrics. Again, this might be something you're about to talk about.
Yeah, we will come to that.
I think the best way to answer your second question is how much are we doing it is when we're going to show you our demo, because that's going to make a lot of sense. We're actually covering that part, the A/B testing part ourselves. So we're going to show you a very good example of how you're going to split the traffic.
Yeah, and primarily what we're concerned with is the infrastructure part. So for instance, in A/B testing, you cannot simply A/B test every kind of model, right? If the payout's not defined, things like that. So it really varies, right? But what we provide is the infrastructure that lets you do that for your own models, right? So for example, how do you shadow a portion of live traffic on a challenger model, right? Like that's the problem that we are solving, not the fact that like whatever model you want to work with, like that's simply up to you. What we want to provide is standardized infrastructure essentially, and give you the ability to leverage these powerful workflows. That makes sense? Any other questions?
I have a question.
Yeah.
So earlier you talked about production testing for ML models. So I come from a software background, I'm a software developer. So what is production? What is the significance of production testing in ML? Because in software world, we are testing our system against finite inputs, right? But in ML world, even if your model is good and you want to deploy it, that still means nothing. Correct. Unless it goes to the real life or vice versa. Mm-hmm. So how would production testing benefit in case of ML? What is its significance?
Mm-hmm. So if you think about like a simple web app versus a ML model, the primary difference is once you deploy the app, it stays there. There's only REST calls or inputs and outputs, but the core logic's the same, right? In ML models, however, it's basically you have a frozen state of your model that is encountered a bunch of training data before, and then it's as good as that last image of the training data it had, right? So imagine if you would go out and put that model out in production. Imagine a use case like a stock trading application, right? So now this model goes out, it's encountering live data, so which is not, so you want to basically track what's the difference that between the live data versus the data that I trained it on, and have a way to determine that if my model's behaving the way I want in that setting, right? So live testing, production testing would happen in the way that, right now, for instance, it's only a siloed process or a sequential process, rather, in a sense that you would just train a model and then deploy it out there, but then you cannot dynamically test on it. So it's taking all of the traffic. So if it's falling in quality, basically you're losing, right? If it's falling in quality against live data and you're serving a production application, that impact would directly be on your end users. Another scenario,
yeah. On top of that, I want to build on that. I think maybe I kind of get your question where you're saying that before even going to the live data, why would we want to test our models in the production setting? Because when it goes live, yes, there's going to be live data and the model is going to deprecate. But why is there a need of actually production testing when it's not even hitting the live data? Exactly, right?
And there would be so many unknowns in data in the future. You don't know how your model reacts.
So essentially, so there are other stuff that is also going on here. When we talk about production testing, we not only mean that the model is deprecating when it's hitting the live data. What we mean is that when you're trying to build a model, maybe it's in TensorFlow, maybe some other model, and when we talk about consistent workflows, right? So when you have some models, maybe there are different frameworks, maybe there are different versions of the same framework. So maybe you have 4 versions of the same model in the same setting. Now you want to take those versions into production. So before that, before even going to that level where you're going to hit those versions to the live traffic, you want to see and you want to test them, deploy them, get some endpoints, hit them some core live data, the data that can be the most near to the live data, and see which versions are the best, and then which version can actually go and hit the live data.
Yeah.
So this is what we mean when we say production testing, because there are so many versions of the same framework. There are so many models of different frameworks, but you have to provide them the same consistent workflow when we come to production. Right?
A briefer answer would be, software testing is perhaps more deterministic.
Yeah.
Whereas machine learning is more statistical.
Exactly.
It's statistical, so you have to sort of figure out the probabilities, acceptable ranges, and that sort of thing.
So even with regular software development, the closest example to what you guys are talking about right now is when you take a snapshot of your production database, you anonymize it, and then you do your development on that snapshot.
Right.
You do your testing on that snapshot. So this is like a more production version of that.
Yes. And one thing I missed earlier is the testing is not just for the ML part, right? There's an infrastructure part here as well. So if you deploy an application in regular software, you typically load test it, right? So load testing using JMeter or a tool like that. That's a typical production practice. Now, your model is also a container, right? And sometimes, for instance, in TensorFlow, there's something called like a cold start. So your model doesn't start right away if it hits the first request. It'll take up some time to boot up. So you also want to test how the infrastructure part of it would behave in production, right? So even before I push it out to my live traffic, I can give it, let's say, like 10,000 concurrent test requests to test how, like, it would behave and scale. So other than the ML part, infrastructure part is also somewhere where you definitely need to test it before it goes out there. Does that make sense?
Sorry, can we now move to the actual workflow?
Yeah.
Then we can do all the questions while we do the workflow.
Sounds good. I think that'll solve a lot of
that'll answer a lot of questions.
Right. So now we're going to show you how we've built, like, a way to do a lot of these things. A lot of these were problems that we faced ourselves, and we realized that there's, like, a lot of options. For instance, you can go to public cloud, use some, like a platform like SageMaker or something like that. But a lot of these platforms first are very limited in the sense that they're tied to that cloud, right? So if you're using Amazon SageMaker, you can only kind of work with S3 and Amazon managed services. So this comes with every cloud provider service. Similarly, things like A/B testing and all these production features, that's something that you'd not typically find in these platforms that are out there. So we wanted to build something that is as sophisticated as some of the platforms we showed you earlier, but which works for everyone, right? So now we're gonna jump into the demo. I'll have another window.
Okay, yeah, sure.
So what we're going to show you is a typical ML workflow, like from end to end through Dataspine, which will cover, and touch on a lot of these things that we talked about. But alongside, I want to show you what happens under the hood, right, from an operational point of view. And so kind of give you a contrast of, what kind of things we are automating. And what it looks like, if it's happening on the background. So Dataspine is built on Kubernetes, basically. So it's infrastructure agnostic, works everywhere. So what we're going to show you is this is a hosted version, but we're going to show you our backend on how things are happening. So I'll just log in. So this is the main dashboard.
Just walk them through.
So I have a few controls here. I can view all the deployments that are on my cluster. These can be ML models, notebooks, other services, things like that. There's specifically service endpoints. So these are all basically the workloads that are deployed on my Kubernetes cluster, but I'm actually not touching Kubernetes here. So for ML, this gives you the interface to work with without going into that DevOps pane. All right, so starting with the ML workflow, right? So the first thing that we'll do is provision a Jupyter notebook. How many of you have manually provisioned a notebook before?
Almost everyone, I think, whoever's
or at some point. So Jupyter is kind of becoming the go-to standard for notebooks. But this is just Jupyter. We also support other frameworks like Zeppelin and RStudio. Those are on our roadmap. But Jupyter has now a lot of rich integrations. So it's a pretty good place to build and train models. So what we're going to show you is creating a notebook instance. Here, what I have is my environments, right? So these actually correspond to containerized environments that we manage. So our base environment basically comes with every popular ML framework built in, but you can choose different environments. Like for machine learning and deep learning, it would come in with Keras, TensorFlow, PyTorch, and all these frameworks. If you want to work in a data science environment, which is more like heavy on R and things like that, you can use that. And we also have Spark, so which would contain kernels for like Scala, if you want to write your code there and things like that. And it would run directly on a Spark cluster that we also manage. The other thing here is we can give it resources here arbitrarily, but we don't go to the cloud provider, right? So here, for instance, this one CPU and one memory corresponds to like one CPU and 1 GB of memory, right? So when I click create, what happened in the background is, yeah. Wait.
You have the cluster running.
Yeah.
Just restart.
Here. So if you look at my Kubernetes cluster, there's a notebook instance that's spawning in the background, and what I can access it directly from the interface. So this is like just a view under the hood that in one click you're actually provisioned on Kubernetes. Here you didn't do any ops, so you're not writing a YAML file, you're not doing like any Docker management. One thing here is these are all containerized environments. So as I said earlier, you can actually like they'll all stay consistent from like your local to cluster or like whatever environment you want to work in, but also these are customizable. So other than these environments, you can actually also we will be building support for your custom Docker image, right? So if you want to install additional dependencies, you can just like spawn up your own environment. But we think that these managed environments pretty much cover everything that typical users would do. So now I'm gonna go to a notebook that I already have provisioned. Just 1 second. Here. So my Jupyter environment is ready, and it comes in with the base environment. So I have Python, a bunch of other things installed, but this is basically ready to code, right? So I can just go here, write some code. Right. So this is basically Python in my browser, but I can provision this environment on any resources I want, right? So basically you can have multiple environments running in parallel. You can stop them whenever you want. And this is where you get to the iteration phase, really fast. Now, once we're in the notebook, that's where you typically write your models. So we don't have, I'm not gonna go and train an entire model for you guys, but I'm gonna walk you through how to take an existing model to production. But before that, let's start with how Dataspine would manage your projects, right? So we have a CLI tool inside the notebook. So you have a full terminal interface. Can you guys see what I'm typing?
Yeah, probably.
Okay.
This is better.
Okay, so this is our command line tool. Almost all of the functionality that you can access through the UI is primarily accessible through the CLI as well. So you have a few command families for cluster management, authentication, model management, prediction, testing, things like that. So let's start with a typical workflow. All right, everyone following so far?
And we would love to have this more interactive.
Yeah,
if
sure.
Just interrupt us anytime you want.
Mm-hmm. So the first thing I'm going to do is initiate a model, right? So let's before that look at what a model primarily contains, right? So there's typically a requirements file that contains all the dependencies for your model. There's a file or multiple files that contain your training logic. There's another file or multiple files that would handle your prediction logic, and then it's the model artifacts and other dependencies. But at the core, you have to have a train, a predict, and a requirements, right, in order for any model to run. So what we provide is a way to automatically create that folder structure, so you can start working in that model right away. Or if you have an existing workflow, you can port it very easily to this, right? So I'll just quickly initiate a project. Dataspine model init. Let's see what are the options. Model name. S will come up with a model name.
Super
Super duper predictor. Predict. Okay, I'm gonna, since I want to avoid typos, super duper predict. And the model tag. So this is the other part, right? I want to version my models. So I'm gonna version this v1. This is an arbitrary tag, just like how you version anything. What's the model type? So we talked about it earlier that we need to have a consistent workflow across all frameworks, right? So whether it's TensorFlow, whether it's Keras, whether it's Python, you should be able to work on these models the same way. So I'm gonna pick Keras here, right? So this is like basically using either a Python runtime or a TensorFlow runtime. I'm gonna, so model type is literally TensorFlow or Keras or PyTorch or scikit-learn. That whatever the model type is, I'd put it there. And then the runtime is what I want my model to run in. So this could be TensorFlow serving, this could be our custom Python backend, this could be a C++ or JVM backend. We manage all of those in the background. So you can just select which one you want. Yeah. Model chip, right? So whether you want it to run on a GPU or a CPU. Here I'm gonna do CPU for now. And then the model path. So where I want my model to be initiated is in the current directory, right? So system files have been initialized. Here you go, right? So right now, what I have here is my entire template for the model. At the base layer, the first thing is the dependency file that I told you about, right? So it already contains the required dependencies that you need for the Keras runtime, plus if you want additional dependencies, you can just add them here, right? So this makes sure that whatever dependencies you have will get packaged into the runtime when you're deploying. So this is the first file. Basically, you just add your own, or use the ones that are already here. This is how you manage the environment. And then there's a setup script. For instance, let's verify if we got the argument right. So we have something set up. The model names super duper predict v1 Keras, so which means that the model was initiated fine. And then I'd come to the predict file specifically, since we're about to deploy a model, right? So this is a generic prediction contract for the model, right? This code is already you have these stubs. What you want to do is write your prediction contract in the predict function. So we have a generic predict API. Whatever you have in here, essentially every model has its own unique sets of inputs and outputs, and then you'd want to transform those inputs and outputs based on what you want to see or what you're consuming, right? So that's the logic that goes in here, right? For every model, it's different. So basically, when you're deploying, the only part you would write is this predict function and update your dependencies and the trained model itself, right? So
just a small question about the code that you already have there. Is that just placeholder code?
So this is basically for another model, this placeholder code. Essentially, you can have your own predict function here, basically.
It's some of the part it would be our model.
Yeah.
So if you go up and you see your libraries, so that you see a gRPC library coming in serving protocols. Yeah. So there are some of the libraries that we'll be giving you, but mostly it's placeholders for you to actually figure out how you're gonna do your predictions. But the train file, the other file that I'm going to show you in a bit, the Dataspine train file, this is the file where your whole model will come in, and you can have other files of your models as well. But this will be the main file if you're running your training job.
Yeah. Make sense? Any questions? Okay. So now we're going to move to the next step. So we have initiated a model. This is where our custom code would go, right? All right, so now I'm in the model itself, and I want to make it ready for deployment. The first thing I would do here is generate a build manifest, right? Now, in other terms, this is basically the Docker image, the Docker file that someone has to write manually in order to take it to production. Now, what we're going to show you is Dataspine model Okay, so I'm going to use the build files, which basically generates a build manifest automatically. So Dataspine model build files. Let's see what arguments this takes. Model name is super duper predict. Model tag was v1. Model type is Keras. And model tag is the current directory.
Yeah. So.
All right. So what just happened here is a Docker file got generated from whatever I had in the directory automatically. Let's have a look at it. So yeah, no one wrote this Docker file. It's automatically generated. What this contains is basically the container image that you're going to take to production. So you can even customize it and verify it before you can take it to deployment. So for instance, these are your input and output paths. Here, the requirements file is all your dependencies, conda and pip dependencies are being packaged. Here, you're exporting other things for the runtime and etc. Right? So this is a Docker file that if you want to customize, you can, but this is ready for deployment, right? And it's basically directly taking in the inputs that you gave it in the last step and your model files here, right? So from here, now this is where we think that this is how ML ops would work in the future is and this is a trend we're seeing in regular software, which is Git ops. So the developers don't touch the infrastructure. They just push to a code repository and everything happens from there automatically. The deployment, the testing and all that. So the developer should only be able to interact with Git and everything else should be abstracted. So that's what we're going to do here. We have some code. Let's push it to a Git repo. I have a sample repo here that I'm going to overwrite. So git init. Super test. Wait, before that, I need to link it. Yeah. All right. Okay, now I just pushed the project or model I had to a Git repository. Standard step here. Okay, so now I'm done with the part where I would work on my model, and here starts the deployment phase, right? For deployment, let's look at how that's done. Dataspine. Sorry, I skipped a step. So once I have my code pushed to the repository, that means it's ready to be checked out. Now I would do the actual container build, right? So I have a Docker file. I want to take my model and package it in form of a container. Let's look at that. So Dataspine model build. It'll ask me for my Git repo. I can add my credentials if this is a private repository. So we'll have Git integrated in the standard Jupyter environment, basically. And then my model name is super duper predict. And my model tag is v1. So what I'm telling it is everything you have in that repository, take this model name and version and deploy it. Build created. Now what is that build? The container is actually being built on the cluster itself through a build job. And you can actually go and view the logs live. So here, the upper one. This is right. Right, so these are all the build jobs that are happening on my cluster. This is the latest one. I can actually go and view my build logs. right? So this is basically the container building process. So you can see that Docker file is now being built into the model itself. So here, for instance, right now it's actually packaging the Conda environment from your requirements.txt here. So now it's actually installing all the dependencies that are in that file for your model. And basically this goes on. What happens as a result of this step is you have a model that gets pushed to your model repo. So the same kind of repo that you saw in the Airbnb platform, this is basically a Docker registry in the backend. And what that lets you do is basically store all your models and corresponding model versions as containers. So they're very flexible to work with, as you can imagine. Like you can deploy directly from the registry, or you can share it with another teammate. If, let's say, Faisal wants to work on the same exact model that I was working on, what Faisal can do is actually go here and go in my model. So this is the model management interface. Once that model is built, it will be pushed here. So let's see if that actually happens.
Quick question in the meantime.
Yeah.
When it gets pushed to the Docker registry, is that public or is that private?
Can be public or private, whatever you. This will be your own registry. So it's pluggable with a standard.
So for demo purposes, we're just showing it's like a general Docker repository, but it will be any repository and it can be public.
Yeah. So you can have a public Docker registry like Docker Hub, which we are using for the demo, or you can have a on-premise or private registry like Quay or something like that.
Does Docker Hub does Docker Hub have a way of pushing private images there?
Can you rephrase your question?
Yeah, not on like where I wouldn't store it myself. Can I like subscribe to?
So you want Docker to be in the middle of the path, and then
I want
pushing that.
I want like wherever the public images are, I want to put my private images there. Is that possible?
Yeah. So you can basically adjust permissions for your images, right? So you can have some public images and you can have some private images. So it depends on you. I think the free plan gives you access to a limited number of private images. So that's a good way to start. However, if you don't want to deal with any of this, the platform will come with a registry that you can use as well.
And most of the enterprise plans that we're working with, they
Yeah.
all want private registries because they all want it on-premise.
Mhm. And there's another good reason to do that, because the latency for pushing and pulling these images will be pretty low if you have the registry on the cluster itself, rather than if it's pulling it from the Docker servers or like a cloud provider somewhere else. So that's essentially you can do both things. All right. So you can see that it actually has pushed the model, and we're going to verify that. Okay. We can actually go and see where it is. So there you go. So this is the model that was pushed in my registry, and I'm going to make it.
So just for demo purposes, we made all the models were public to be sure in the UI. So we're just going to make it public, and you're going to see that in the UI. I think it should come. Yep.
There you go. And along with this, you'll also have access to whatever model variants or versions that you've pushed, right? So for Super Duper Predict, we only have V1, and it'll give you all the size of the image itself, the architecture it's built on, and other associated metadata. We have a few other models that we were working on. This is like an image segmentation model.
If you go to CCFD,
there's credit card fraud detection. We have a whole bunch of versions here that we were. So for instance, these versions can correspond to anything. They can be different variants of let's say if you're testing different hyperparameters, or if they basically up to you and your experimentation workflow.
And you keep track of those hyperparameters that match to some tag that you've assigned to it.
Exactly.
Yeah, right?
Everything within that model folder, including the metadata, the files itself, all of that stuff is in this container, and you can basically not mess around with it anymore. So that's the beauty of containers, that you can just you have the ability to work on them or deploy them anywhere or scale them, whatever, but they'll stay the same.
In the future, let me know if I'm asking too much, by the way.
No,
In the future, are you considering, for example, actually showing those hyperparameters on your user interface and allowing them to be edited inside the user interface? So if let's say if I don't want to go through the whole process, I just want to change like 2-3 hyperparameters and just run like a super fast experiment.
Mm-hmm.
Is there a plan to put a feature like that into your setup?
That's a great point. We have plans on updating these models. So certain things in this model, for instance, you can they're pluggable, right? So for CCFD and a certain version, you should be able to connect and detach different data sources to it, right? So that's something you will be able to do within the UI, and then it's highly model specific at this point. The hyperparameters, that's why we're not doing that right now, but we will be looking to standardize more and more of this to fit the ML workflow itself, like we have standardized the infrastructure part.
Yeah, so we can do something like the kind of stuff that we are creating for the predict files and all that. So even though they're also model specific, but we came up with a way to actually do some stuff thing. So we can actually in the future come up with a way we can actually have some kind of a generic thing where you can change some hyperparameters according to the model.
So it would be really cool to do like cross-validation on
True.
this, for example.
Mm-hmm.
True.
Absolutely.
That's absolutely. Yeah.
All right. So now my model, starting from the notebook, is now pushed to the registry. So now this can be shared across teams, people, or can be deployed or pushed into the rest of the pipeline. So let's come to that step. I want to deploy super duper predict, but I haven't trained it, right? So I'm going to show you a model that we've already trained and how quickly it is, and simply you can deploy it basically. So let's look at CCFD. So this is a credit card fraud detection model. It's essentially an autoencoder, and it's built on Keras using a TensorFlow runtime, typical credit card fraud detection use case. We have 2 variants of this model. Essentially, these can correspond to 2 different versions of the model based on hyperparameters, or it can also be that V1 was trained yesterday and V2 is my latest model. So it can be any of these. Now I want to deploy it on my cluster as a microservice. What I'll do, deploy. What's my model name? As CCFD. Let's deploy V1. There you go.
Yeah.
Now,
So go to the deployments. Yep.
there you go. 7 seconds ago, my model was deployed on the cluster. Now, let's deploy another variant, right? At the same time, since we are talking about iterating at scale. There you go. So these are actually microservices that are now deployed on my cluster, and they're not just simple containers. They're load balanced. They come built in with all the metrics endpoints, for both the systems, and you can plug in custom metrics to write to your own dashboard, something like that. And this has the ability to auto scale. So essentially, I can go and scale this deployment to 3 here, or I can set up auto scaling on this, and basically my model will scale to the whatever amount of requests I want it to meet, right? So this is, especially auto scaling is great if you have a scenario at 10 a.m. you get like 1 million requests on your model, but at noon you suddenly get 10 million, right? How do you preempt a scenario like that? So that's where cloud native architectures like Kubernetes are really, really kind of built for this, right?
Question.
Yeah.
So what about stuff that is my background in infra is super low, so not my question, but what about stuff that is let's say, latency sensitive? And if you cannot have a lot of latency, as you said, you guys have something on-prem as well.
Yeah.
How does that work? You still deploy, a cluster, and then you have your model being pulled, but then this would go to the cloud, would that also go to the cloud?
No.
So this Kubernetes cluster can run anywhere. So you can actually replicate the exact same workflow that I did on a data center.
Same interface, same
Yeah.
workflow on your data center.
And that's a very good question, right? So that's typically the problem you would face if you're working with a cloud provider ML platform, right? So some of that deployment, either it's on your own app or if it's in a, let's say, a regulated setting like healthcare, finance, those models cannot be deployed on the cloud. So how would you tackle that portability issue? So that's why we've built this on Kubernetes natively. So everything in this platform is a Docker container, and essentially you would replicate the same functionality on either a public cloud or a hybrid cloud or entirely on-prem. It's up to you. So now let's look at the models we deployed. This is basically a list of the models that are deployed live on the cluster. So as we deployed CCFD v1 and 2, we have these here. Now let's find out the endpoint for this model, right? So essentially at this point, I should have an API endpoint that I can use in my application, right? So let's look at that. All right.
Sorry, but just in case anyone wants this beer in the fridge, there's an upgrade.
All right. So it says that my model is deployed, but let's see. Dataspine model endpoint. I'll give it the name of my model.
Oh yeah, this is it.
There you go. So my model's exposed behind this endpoint. Now, one thing here is which variant, right? I just deployed two models, like CCFD v1 and v2, but this is giving me a singular endpoint. Right. So we'll show you why we're doing this. You have two models. Let's say you wanna, v1 is from yesterday, and that's currently deployed. v2 you just deployed. You want v2 to just see 10% of the traffic, right? Or 50% of the traffic when you're taking this to production. So this is how we do continuous deployment, in the sense that you have models deployed. This is actually, behind this is a service mesh. So you can dynamically route traffic to your deployed models and actually test them in real time, right? So what we're gonna do here is create routes for this model because we wanna test it now. So basically this endpoint's gonna take in some requests, but we will define the policy for it. So let's do that. Dataspine predict. So I have two families here, predict, route, and test. I'm gonna route first. So the thing I want to do is, let's say, split traffic 50-50 between v1 and v2. And both are live on the cluster, so let's do that. So model name. So this is where I would give each of the tags its respective weight, weight of the traffic that we want it to receive. So here, for instance, I want, oh, sorry. I want v1 to get 50, 2 to get 50. And then there's an option for shadow traffic, right? So it can also be that v1 receives or v2 receives all of the traffic, but there's some shadow traffic that's going on to that model that's kind of sitting and behind. And that's how, for example, you would do A/B testing, right? So you want to have two variants, you want to see how they're behaving with live data, right? So
sorry, I have a
yeah.
So this is sharing traffic between two different versions or two different deployments of the same one.
So essentially, what we do, yeah.
So it's basically no,
so it's two different versions.
How about the time when I want to share the same version,
you just give it v1 and give it all of the traffic, for example. Yeah. So here, yeah.
I mean, my v1 is probably deployed. I have two v1s.
Mm-hmm.
They're deployed on two different infrastructures. And I want to share traffic.
The process would be the same for both of the scenarios that you described.
Yeah, exactly. Because if you have the same model with the same version and it's deployed on two different things, at the end of the day, there are two different versions. So basically, you're trying to split traffic with 2 different deployments because they are deployed at 2 different points.
Okay.
Yeah.
So you are versioning them based on your deployment.
So it depends. Like actually, the original ML workflow is, because this thing is important, because actually there is one model and people build different versions with the same model to test. It's the same thing we're talking about production testing. So this is the thing, but the test is like, there's one model. So there are 5 versions of the same model. So they would have 5 different deployments, and they will test of like which model is acting which way. But if you want to have the same model, and if it's deployed on different infrastructures, kind of you having these 2 versions, and you're trying to test on different infrastructures.
So a good use case for this would be, like I push out 5 different model variants, and I actually extend my validation phase in production. Right now, model validation happens offline, right? So you basically do a train and test, split, and you do that. But here, you can actually train a model and carry out the validation phase in production, right? So that's cool, because you can now test how your model's behaving against actual data versus the test data that you gave it, right? So here I have a 50-50 split between V1 and V2, and I don't want to keep any shadow traffic. So basically, all of the traffic either goes to V1 or V2. So I'm going to leave this empty. And here, my routes are configured. So now, essentially, if I hit the endpoint that I had above, I should be directing traffic to both of them equally. Let's see.
If you could go into CCFD directory, because we are trying to predict that model.
Yep. So here, let's look at what we're actually doing. So this is the model that we have packaged. So it's
go to input.
Yeah.
Okay.
Yeah. So this is, for instance, the notebook for this model, right? It's an autoencoder model, and then as a result of the training run, I see they're the same files that we showed you. So same directory structure, but here I have like the model files as well, right? So this is the H5, the model binary itself. So this gives you a sense that this is a real model that was packaged entirely the same way that we did with SuperDuper Predict. And now we're gonna take this out to production. So here, the output of this model is actually a confusion matrix. So what we wanna have as Y, or our prediction, is that the confusion matrix, for example. But this can be any output of any model. So let's go back, and here's where we would do a load test, essentially, before even the model goes out live. That's also
part of the 2
so the cool thing here is this model variant, you can actually also pull on your local machine and work on it the same way. So this is how you can actually consistently keep the environments between like laptop or cluster, exactly the same.
Can you just pull the repo?
The entire repo, for Docker.
The Git repo.
The Git repo. Yeah.
And like let's say a second person joined the team. They want to work on that same model. Can they start the process by just pulling the repo?
So if they want to work at a code level, they would obviously work, pull the, but if operations wants to work on it, let's say you want the entire application, model application, you want to test it the way exactly it will be in production, you can just download the entire container on your local machine and just go in and run on it.
Even though if you have a second person of the team, you can just pull the repo. If you want to build the manifest on top of that, it's directly integrated with Git. So if you have the repo, with anyone who has a repo, you can actually do the whole process.
And similarly, when you're deploying that, the other person would just push to the Git repo, and the exact deployment workflow can happen for their version of the code as well. Make sense?
If somebody pushes a tag that already exists,
that's a good question. Right? So we haven't handled logic for that yet, but that's a good one.
It's a total edge case. I was just curious.
No, that's a good one, because we are fixing that in the next.
Exactly the kind of stuff we want you to do. Great. I'll do that.
Okay, so if you go to the CCFD directory.
So what I'm going to do now is the model's deployed. I want to give it a test request. So I have a test request already built for this model. It's basically a JSON file that'll give my model some test data values, and it'll give me that confusion matrix, which will tell me how many transactions are fraudulent, etc., based on whatever model I have. So let's go here, and I'll switch to the. All right, so here's my test request. Let's test the model against this test request.
If you can just like pull this,
What?
pull the screen up.
Yeah.
Yeah, make the
Here's my predict test.
Right. So predict test asks me for what model I'm testing this for, which is CCFD. And then the test request file, which is in my root directory. And then the concurrency, right? So I want it to give 20 concurrent requests to test my model. Yep, there you go. So
this is just because we're cheating.
yeah,
That's why
so V1, V2, V1, V, no, so initially it stopped because remember I told you there's a cold start for models, right? So this is why you want to load test, because if you will directly take out a model to production without giving it a request, it won't respond to that request. So this is why load testing is important before you push it to production. So let's say you can tell that how much time it took for the model to start, right? So here, for instance, it's giving me the latency for every request. As you can see, for example, this is like higher than this one, and then it's going down further. So as I do it more, it's basically scalable, right?
Is that the first one?
No,
the first
no,
one
no.
was like
There's
3 or 4
a
milliseconds.
Yeah, okay,
Yeah.
that's what I was. Yeah, exactly.
there you go.
Yeah, it's like 300
Makes sense?
milliseconds.
And
So-
if you remember, we actually tried to like split the traffic between
Yeah,
one and
Yeah,
Exactly.
so it's doing a 50-50 split, for instance. Half of these requests are going to V1 and half are V2 by divide.
Can you like in the request endpoint,
Mhm.
can you say which version you want? Like, can you tag the version that you wanna predict with in the URL itself?
So that's something that we haven't given the control of to the user, because we are load balancing the model, right? So we
Gotcha.
want the only entry point for the model to be that ingress for the service, and then we treat all versions as something you can handle dynamically. So for instance, like the thing that you want to do, you can simply do with routes,
Yeah, yeah.
and it would do the same thing without actually messing up with the model. So
I feel like that's where the confusion was coming from earlier as well. I feel like your software has two types of versions. One version is for the deployment, and one version is for the software part itself. Let's say someone goes in and changes their training logic, right? This is a code change. That has different versioning.
Mhm.
But when it comes to deployment, it has many other things too. That training change as well, but many other things as well. So it looks like there are two levels of versioning in your system.
Yeah,
So
the tag is different.
Yeah. So based on his question, I feel like probably you might want to create two different levels of version, because when you develop an API, and I guess you are writing an API yourself, right?
Mhm.
So versioning in URL or versioning to header tags, that becomes really important. Maybe at this point it's not.
That's eventually going to be the case. Yeah. So that's a great point. I think the challenge here is versioning in ML experiments is different than versioning in the containers themselves, right? So that's something that there's ambiguity around, but we will be looking to make this more consistent throughout the user experience. So it's more intuitive.
It's only because like if somebody, like to this point, if somebody wants to do A/B testing with their own logic, and then they just want like they just want the different endpoints of the different deployed versions of the model, and they want to keep the A/B testing logic on their side of things. That would really help. It might not be necessary for you guys today, but I think like as you guys scale, it'll be super useful to have that.
Absolutely.
Because I know
let's
like
note that
we work with just bigger companies, and when once they start using your software at a bigger scale, for them change is like a death. Like, oh, this is a big change, we are not upgrading. No, you cannot upgrade that. And that's where you get into these discussions. Okay, we will keep one version for you, and we will move other clients.
and then it becomes hard to stay consistent.
Absolutely.
That's absolutely the case. All right. So I think we're at the point where we have received predictions from a model, right? So this is typically the point where after which you would monitor the model if it's out there on latency or accuracy. So accuracy is something that's highly dependent on the model itself. So we don't have that built in yet, but we're trying to abstract it more and more so you can have a way to log accuracies in like from any kind of model, right? And like the framework that you're using. So what we essentially just walked you through is like an end-to-end workflow from like, a notebook provisioned to a deployed model endpoint. And this very model endpoint can actually take millions of predictions right now if I turn on auto scaling. Like this is on a Kubernetes cluster. So if I want to like,
Yeah, one more suggestion.
Yeah.
It's up to you. You want to take
Yeah,
it or you don't. So when we do auto scaling, and because you're working with cloud environments, so it's pay-per-use kind of model. So when you're doing auto scaling, someone is expecting, let's say they don't expect 10 million requests overnight, and it happens. They might be able to fit that into their budget. They might be able to pay for those 10 million requests. But if auto load is left as it is without any upper threshold, that person might not like it. So maybe even with auto load, you have to put in these conditions that
a maximum or something.
Yeah, the maximum.
Exactly.
Because some clients would definitely won't be happy with that. Say, okay, we can pay, let's say, 1 million, but we cannot pay 2 million for this. We never planned for this. And just probably want to give the control back to the client that they set this amount.
That's a terrific point. In fact, the next module that we're building on this is the policy management, right? So that's more for the management of these models in which you can actually set policies for something that you mentioned, right? So I can, let's say, put on a quota, like first of all, for the auto scaling itself, that, if only it reaches 90% of the current load, then form a new replica, things like that. But also set, because this is all built on Kubernetes, so just similar to how we manage the CPU and memory for the notebook, we can actually manage the CPU and memory for anything that's on the cluster, right? So we actually have capped limits in the background, so you can do it beyond a certain extent. But for, let's say, if you want to use the enterprise version of this, it come with the policy management dashboard where you can actually do this on your own. So a good use case for that would be like, if I have a data science team who is spinning up a bunch of these notebooks, they want to have as much as they want, right? So like 10 CPUs and 10 gigs, but I might not have those resources on my data center, right? So the manager can actually define a policy that, hey, every data scientist can only spin up this, right? So there's a manager part of this, and then there's the user-facing part.
That's something we haven't seen anyone else do. I think that's probably going to be the first of its kind for a tool like this.
Yeah, honestly, ML ops is such a new field that a lot of these things are being built for the first time, right? Like we just wanted to do this because we think that there's great DevOps tools for regular software, but you don't have that for ML, right? And if you're an ML or AI first company, you have to do all these things on your own, or you suffer, right?
Basically. You don't want to spend time
exactly
figuring out the things that you're doing every single time.
Yeah.
It should just
It's so funny because Farooq just sent me a screenshot of Uber's PyML integration into Michelangelo 2-3 days ago. And just a week before that, he was showing me that exact same feature on our architecture.
Right. So what you saw in PyML, for instance, on the left-hand side, there was a requirements. There was a template basically that gets converted to a Docker container, right? So we've automated that process basically. Even at Uber, data scientists still build their own directory structure and then put in all the dependencies and files and all that. So we're definitely moving towards automating and abstracting more and more of this. And that's why we would actually love to have your feedback on these things as we build this out.
One more thing is not a question, it's more like a comment. So what I gather from this presentation is that Dataspine is essentially an abstraction of logics, different types of logics you have there, and you are interacting with APIs of different other tools to make things uniform. It's a good opportunity to grasp on, especially at this time, but I also feel like you guys would have so much trouble as well catching up with new things because there's so much variation. There's so many new things coming up.
Great.
You might wanna, it's just like you'll be chasing.
That's exactly true, and that's something we faced ourselves when we were building this out. So the purpose of creating Dataspine was so we can manage it and not you guys, right? But as you said, this is this is the reason why building in-house is so painful, because I can build like a setup that's on TensorFlow 1.0, like, today, but TensorFlow 2.0 has an entirely different API, and like, it has a new, so who will maintain those binaries and like, everything? So let's say if I want to start a notebook, I want the latest version of everything. Right now it's manual, right? And that's something that we are automating through this. So yeah, you're right. This is a lot of work to keep up with. And that's exactly why we've been working on this for the last 2 years.
In terms of architecture, I think I've mentioned it a couple of times during the talk. We've specifically kept it in a way in which it is trying to be as technology agnostic as possible. So we're as flexible. We're not betting on a single framework. We're not betting on a single hardware platform. We're not betting on what kind of neural networks will be successful in the future. We're betting on a process of how you build smart applications.
Yeah.
And that's this way which we validated from bigger companies like Google, like Uber, Netflix, and so on.
How do I get into the beta? Like, how do I get
sign up on the website and we'll give you access later.
In fact, would love if all of you sign up. We'll actually send you email links
for our access. Yeah. And the reason we wanted to have you guys as our first audience pool is because we want to work through your problems on this, right? So we want to know what you're facing every day in your workflow and how we can optimize that for you guys. If we can help solve some or most of your problems, I think that's exactly what we're trying to do here.
I have this very, very small suggestion. It's almost like you don't have to do it right away, but if you could just pass those variables when you run a command directly into that first command with
it's already there.
Let me.
It's already there.
So you can do it both ways.
Yeah.
We just wanted to make it a little more attractive right now, but it's already there.
So you can pass the parameter straight away.
Awesome.
Here, let me show you.
I believe you, man.
No, the reason I say that is because I'm a fan of one-liners.
Yeah,
right?
exactly.
So,
at least for the
yes. So I love it.
In jokes.
Huh?
In jokes.
I'm trying to get better at the letter, but no, that's a fine point, and that is why I'll show you how this works. So here I'm in my home folder, and the project creation is one command here.
Sweet, yes.
So all the args that so for more intuitively you can follow the prompts, but if you want a one-liner like I like them, you can just
and this is going to be 3 different layers of work, right? So there's one-liners, then there's those prompt-based,
and then there's
complete UI. Yeah. So we what we're discussing this. We were at CIBC yesterday.
Yeah.
So we were meeting their head of innovation banking, and one of the things that he was talking about is that a lot of people want to use machine learning into their business processes, but then they're scared, even though they have a basic level of understanding what this is. And that's part of the thing that we want to abstract away. We want to make it less scary for people. So if anyone remembers Heroku, so that's
same concept.
Yeah, exactly.
Yeah.
Awesome. I also feel that on top of that point, many people in industry, they want to, this is cool, working on AI and ML things. But many people do not have the clear understanding of that as well. So what they present as machine learning problems are actually not machine learning problems. They're software development
absolutely
problems.
right. Yeah, there's a lot of noise. You're spot on.
And that's exactly why we put in the second image, right? So ML code is actually very little part of it. If you're looking at the ML journey, ML code is something that you will find as one of the easier parts of the job. If you want to take it to production, because there's so much else that you would want to take care of. So just to wrap this up, do you guys have any thoughts, suggestions, questions? I think we had quite a few going on here, but by you guys, Jeff.
We can do that over pizza and beer.
Actually, let's do that.
That's
all right.
People are
Thank you. Thanks a lot for coming by. Appreciate it.